Hi, everybody. Welcome to STEM Buddy's second workshop for our research program. Today, we'll be covering how to develop a hypothesis, rationale, and experimental design. So here is our updated tentative schedule for the program. So due to some scheduling conflicts, we had to move our second workshop to Monday, July 27th, which is the video you are currently watching. And our third workshop will be released on Tuesday, July 28th, but all other workshops will be released as scheduled. So I just wanted to cover some housekeeping because we realized there was a bit of confusion from the first workshop because we didn't really explain to you guys what exactly a research proposal was. So a research proposal is a document explaining what you plan to study and how you will conduct your research, and it's written before a study begins to convince others that your research is worthwhile and feasible. So in your case, you will be developing a research proposal to present to a panel of judges at our physical in-person symposium, and you will be convincing that panel why exactly your topic is interesting and important to the scientific community. So we also wanted to explain to you guys what a typical structure of a proposal is. And obviously, from this long list of aspects, you can see that a title, abstract, introduction, research question, hypothesis, literature review, experimental methods, expected results, conclusions, and references are core components of a proposal. And you guys have obviously decided on a topic or your title and developed your research question. And today we will be learning about a hypothesis, rationale, and experimental methods. So those aspects are highlighted in green for you. Everything else that hasn't been covered yet, but will be covered in the next slides have not been highlighted. So those are currently just white. So today's learning objectives include your hypothesis, rationale, and experimental methods, as mentioned before. And we'll start with our hypothesis. So you might be wondering what exactly is a hypothesis, and that's a clear, testable statement written in the present tense that includes practical reasoning, and it's constructed before any applicable research has been done, apart from a basic background review that you might have conducted just so you got a good idea of what exactly you want to research. And a hypothesis is not an opinion or prediction, it's just a reasonable expectation based on current scientific evidence. And you might be wondering, can you change your hypothesis? And yes, of course. Even if a hypothesis is supported by strong scientific evidence, it can still be rejected because evidence is always emerging. So sometimes when scientists encounter new evidence that sort of doesn't support their hypothesis, they might decide to expand their hypothesis or revise it to include that new information. And now we'll be looking at the characteristics of a hypothesis. So a strong scientific hypothesis should meet the following criteria. So a hypothesis should be testable, meaning that you can collect data to support or reject it. It should have independent and dependent variables, which we'll touch on in the coming slides. Essentially, an independent variable is a factor controlled in research, and the dependent variable in your hypothesis is a factor that will be measured. And a third component of a strong scientific hypothesis is that it can be observed and quantified. And a fourth aspect of a hypothesis is that it should clearly define your expected outcome. Now, another important aspect of a hypothesis is that it's often written in an if and then format. You might have seen that in our previous workshop. Ananya provided a similar template, but by no means you don't have to follow this exactly. This is just sort of something to help you when you're first developing or refining your hypothesis. Now let's look at an example of a good hypothesis and apply what we learned from the previous slide. So over here we have the example of students who use an AI chatbot for 8 weeks will have lower HAM-A scores than students who did not use the chatbot. So HAM-A is essentially a tool or survey used to measure anxiety. And to shift your focus to the left, let's look at the components of a good hypothesis and compare it to our example. So Clearly, this hypothesis is testable because you can personally assess whether AI chatbots can reduce anxiety effectively. It also has independent and dependent variables. So the independent variable here is the mental health chatbot because that's what the researchers have decided to control or present to the study population. And the dependent variable is the HAM-A scores or anxiety, sorry, it should not be stress, anxiety, because that's what is being measured. And obviously, this hypothesis can be measurable because we are assessing patient HAM-A scores. And it's also specific because we are clear about the fact that we expect the experimental group to have lower HAM-A scores than the control group. So let's move on to the second aspect or learning outcome of today's workshop, which is learning about a rationale. So a rationale is essentially a brief explanation of why you think your hypothesis makes sense. So it connects your hypothesis to background research and it shows that your hypothesis is not a guess, it's based on scientific evidence. So you might be wondering, why would we write a rationale? So here are four reasons why you should include it in your proposal. So firstly, it shows that you've done some background reading, so you know about current scientific literature on your topic and you're well informed to make a good hypothesis. Second reason is that it makes your proposal more credible. A third reason is it justifies the significance and novelty of your study. So essentially, when you write a rationale, you explain why exactly your hypothesis is important. And part of that is explaining why it's new, why your hypothesis or research proposal will provide the scientific community with important knowledge. And it also helps exemplify critical thinking to show that you really understand the topic that you're studying. So some couple characteristics of a strong scientific rationale is that um, are the following. So your scientific rationale should be concise, so it should be around 4 to 5 sentences. It should have a good amount of scientific evidence, so it should reference facts and prior studies. It should also be clear, so your scientific rationale should define the research problem. It should also have purpose, context, and impact as well. So from this example, I'm not going to read it out loud because it's sort of long. Obviously, it covers the previous sort of markers of a strong rationale. And it's also a good example because it's persuasive and it makes a convincing case for why this research is important now. And it states the actual benefits for patients and healthcare systems. So, in your own time, you can sort of use this checklist and compare this example and see and sort of think to yourself why exactly this would be a good rationale. So here are the steps to write a rationale. So first of all, you want to write a background based on all the research that has been done on your study topic. Then you want to follow this with what is missing or what are the open questions of sort of all the research that has been put out on the internet. So, for example, if your topic is AI chatbots and their impact on anxiety, maybe a question that hasn't been answered is um, what are the impacts of chatbots on women aged 65 plus? And patients who have anxiety. So you might want to focus your rationale or hypothesis on something that hasn't been done like that. And then you want to identify the gaps in existing research or specific problems that current research hasn't addressed. So going back to my previous example, this is sort of the same thing. And then you want to explain the significance of the study and why it is important. And then you want to clearly define what your study aims to achieve. And then lastly, you want to briefly explain your methods. So now we'll move on to our experimental design learning aspect. So you might be wondering, what is an experimental design? So an experimental design is essentially a set of procedures that describes how you will conduct your research and collect your data. And this data is important because it will help you support or reject your hypothesis. So some characteristics of experimental design you should include in your proposal are research designs, your study population, general procedures, and your data analysis plan. So essentially, a research design is how you plan to set up your entire study, and these three examples are some common ways to do that. So a cross-sectional study is when you gather data from a single point in time and the researchers do not actively assign groups. A cohort study is when researchers follow people over an extended period of time to see who develops a specific outcome, and researchers do not actively assign groups. And a randomized control trial is when a study is done over a shorter period of time, and researchers typically split participants into groups randomly. One group will be the experimental group that gets a new treatment, which is the independent variable, and the other group is the control group, and they receive standard care. So you might be a little confused about what exactly these are. So we decided to prepare an example to illustrate the differences. So going back to our hypothesis that students who use AI chatbots will receive lower HAM-A scores or reduced anxiety than those who won't, we'll apply that hypothesis to these three examples. So over here for our cross-sectional study, let's say 500 students were surveyed about whether or not they used an AI chatbot, and then researchers decided to measure their anxiety using the HAM-A survey, and then they compared anxiety levels between AI users and non-users immediately after they completed the survey. In this case, the researchers have only observed participants at one point in time, and they didn't assign the control and experimental groups themselves. They simply just selected um, a couple participants and asked them if they were currently using an AI chatbot or not. So over here, the researcher again didn't decide who uses who used the AI chatbot or not. In the cohort study, researchers also don't assign groups, but instead they follow people over time instead of assessing scores immediately after surveying them. So again, 500 students are recruited, and then they're asked if they use a mental health chatbot. Again, as you can see, the researchers do not explicitly tell which students to use, which students should use an AI chatbot and which students should not use an AI chatbot. It's just based on what they're currently using. And then the students will be followed for 12 months, and their HAM-A scores are measured every 3 months. Over here, this demonstrates that the researchers are following participants over time. They're not assessing their scores immediately after completing their first HAM-A assessment. And then at the very end, they will compare how their anxiety or HAM-A scores have changed over time. Now, shifting focus to a randomized control trial here, the study timeline is often shorter and a researcher actively assigned groups. So again, for example, let's say you recruit 500 students, and then over here now the researchers will randomly assign 250 participants to use an AI chatbot and randomly assign the other 250 to a control group, meaning this group will not use the AI chatbot. And then they'll compare their anxiety levels or HAM-A scores after 8 weeks. So in this case, the researchers are tracking the participants over a shorter period of time, and they have decided who is using the AI chatbot and who isn't. So this is just sort of a way to illustrate the differences between these three research designs, and it is up to you to decide which one you think fits your hypothesis the most. Now let's move on to the second aspect of experimental methods, and that's choosing your study population. So when you're thinking of developing a study population, you should think about the population specifics. So you should clarify the number of participants you want in your study. So whether that be 200, 500, 1,000. Typically, having more participants is better because that ensures that your data is more generalizable to a broader population, therefore more credible. You also want to clarify the demographics of your population. So that includes age ranges, genders, ethnicities, and geographic locations. These demographics may not be applicable to every single population. They are just factors that you may want to consider. Some other requirements you may want to consider is whether or not this population actually has a condition that you're trying to alleviate. So, for example, if your hypothesis is about AI chatbots alleviating anxiety, you obviously want to recruit participants who have some degree of anxiety because that would help demonstrate whether or not your interventions are effective. Additionally, when you're choosing a study population, you should also explain why your chosen population was a good choice for your study. So, for example, if you decided to choose university students as your study population, you could say that this was a good choice because they experience relatively high levels of academic stress, making anxiety a common mental health concern. So this would make your participants a good choice if your hypothesis was aligned with AI, chatbots, and anxiety. You could also say that this age group is familiar with digital technologies, which would make them more likely to engage with AI-based interventions. In contrast, if you chose a population that was in their 70s or 80s, they may not be as familiar with technology or AI, and they may choose to not follow through the procedures you have instructed them to complete. So another part of creating experimental methods are your procedures. So you should consider your study duration, how you'll enroll your participants, baseline assessments, random assignments, and participant monitoring. I'm not going to list out every single question under these subsections of procedures, but you should look at this list and apply it to your research proposal. So to your right, we have an example of a procedures in the experimental methods section of a hypothetical research proposal. And to your left, you have the same checklist as these as presented in the previous slide. The first aspect of a good procedure is to list the study duration that you're planning to implement. So to the right, you can see that this person has decided to design the study to last 8 weeks. The second aspect of an experimental methods procedure is to list the participant enrollment. So to the right, you can see that participants are expected to provide informed consent, and they are expected to complete a baseline assessment using the Hamilton Anxiety Rating Scale. So again, HAM-A. In green, we have another aspect of experimental methods procedures, and that is random assignment. So this person has decided that participants will be randomly assigned to one of two groups. So this would be like a randomized control trial. And then finally, a last aspect of the procedures section would be your post-study measurement. So this person has decided that at the end of the 8-week intervention, all participants will complete the HAM-A again under the same conditions to measure how effective the AI chatbot was in reducing anxiety amongst the study population. So that concludes today's workshop. I hope you guys enjoyed learning about the different aspects of creating a hypothesis, rationale, and detailing your experimental method sections. Again, as always, if you have any questions or concerns, you can contact us in our Discord channel. Have a lovely day.